So I hope that all of you have understood the details about the groups and why groups are numbered like that. Now let us move ahead to the second portion of the periodic table, the second salient feature, and that is periods. The periods, you can see, are numbered from 1 to 7. They are also not numbered without any reason. As you saw in the case of groups, they are numbered according to the valence electrons of the elements. Each and every element belonging to a group has the same number of valence electrons to the number which is assigned to that group. So the group 1 elements have 1 valence electrons, group 2 elements have 2 valence electrons. Now in the previous video I got you confused by saying I will be explaining the periods. Now let us just try to understand and get rid of that confusion, that I wrote electronic configuration of aluminium 2, 8 and 3, and I said you that this belongs to the 13th group. But you will say, sir, it has 3 electrons in the outermost shell. That means the valence electrons is 3. So it should belong to the third group. It should belong to the third group. But if you remember in the previous videos I said that groups from 13 to 12 will not be studied in the chapter. The first reason why aluminium does not belong to the third group, because group 3 to 12 elements will not be studied in class 10 because of certain assumptions and the level and the standard of class 10 students. Now if you find 3, 4, 5, 6 and 7 valence electrons, if you find these electrons in the outermost shell of any element, these number of valence electrons in the outermost shell of any element, you will not say that they belong to the third group, fourth group, fifth group, sixth group, seventh group. Rather they will be belonging to the 13th group. 3 stands for the 13th group, 4 stands for the 14th. These are the assumptions, okay? 14th group, 5 stands for the 15th group, 6 stands for the 16th group, 7 stands for the 17th group. So till 1 to 2 you will directly say the one, if it has 1 electron in the outermost shell, 1 valence electron, first group, 2 electrons in the outermost shell, 2 valence electron, second group. But if it has 3 electrons in the outermost shell, it will not belong to the third group, because I said you groups from 3 to 12 will not be studied. So that's why the third group elements, 3 valence electrons means 13th group, 4 valence electrons means 14th group, 5 valence electrons means 15th group, 6 valence electrons means 16th group, 7 valence electrons means 17th group. So in the case of aluminium, it has 13 electrons. That is, the atomic number of aluminium is 13. So if you write the electronic configuration, it is 283, and 3 from here, from this rule, is 13th group. Okay, and you can check it from the periodic table. It belongs to the 13th group and not the third group. Now let me explain you how I am writing the electronic configuration, which is very important. Electronic configuration. Electronic configuration is the grouping of electrons. Okay, and determining how many electrons will rotate in a particular shell. And the rule is very simple. What is that? The first shell will have 2 electrons. For each and every element, the first shell will have 2 electrons. Then you have to give 8 electrons to second shell, okay, comma, you have to give a comma. So the first shell will have 2 electrons, the second shell will have a maximum of 8 electrons, and the third will have a maximum of 8 electrons, and so on. So this is the rule which we have to follow for making the electronic configuration. So if you take an example of potassium, the atomic number is 19. So how I am going to fill up the spaces using the atomic number. It has 19, so I have taken 2 electrons, so it will go to the first shell. How much left? 17. Now I will take 8 electrons to the second shell, so 2 plus 8, 10. How much left? 9. Again I will give 8 electrons in the third shell, so how much left? 1. So you can give 1 electron in the outermost shell. So the first shell will have a maximum of 2 electrons, and the third and the second and the third will have 8 electrons as maximum. So this is how I have partitioned, this is how I have grouped the electrons from this number. 2 in the first, 17 left, 8 in the second, 9 left, 8 in the third, 1 left, 1 in the last. So this one is the valence electron. This one is the valence electron. And this is very interesting. So if you know the valence electron of any element, you can say to which group that belong, to which group that element belong. Okay, so you go and check potassium. I have said that the the valence electron is 1, so it must belong to the group 1. I'm showing you, it belongs to the group 1. It's very amazing. It belongs to the group 1. You can see this potassium is over here, okay, and it belongs to the group 1. So you understood what is the use of knowing the valence electrons. You knowing the valence electrons. Okay, now let us move ahead to the periods. So periods are numbered from 1 to 7, and they are horizontal rows. And why they are numbered 1 to 7? Because of the number of shells. So as you have seen in groups, that the group numbers, they give you the idea, the number of valence electrons, the number of valence electrons are fixed. Similarly, the periods, they give you the idea, the number of shells. So these are the number of shells: the first shell, the second shell, the third shell, the fourth shell, also known as orbitals. First orbital, second orbital, third orbital, fourth orbital. We will be using shell, which is very easy, which is easy to understand and to comprehend. The word is simple, shells. Okay, so in periods what happens? Shells remain fixed. So if you see in this first period, if you see in this very first period, it starts with hydrogen and helium. The number of shell will be 1 because they belong to the first period. In the second period, the number of shells will be 2. In the third period, the number of shells will be 3. In the fourth period, the number of shells of each and every element will be 4. I'm explaining you by giving an example. What do I mean by this? Okay. In periods, what happens? Number of shells remain fixed. Try to understand by a simple example. So let us take the first period. As you have seen just now, that the first period elements are hydrogen and helium, isn't it? I said to you that first period means all of the elements belonging to the period will have the same number assigned to that period. Okay, the same number of shells assigned to that period. In simple words, first period means the elements will have only one shell. Let us try to prove this. Hydrogen, the atomic number is 1. Helium, the atomic number is 2. So if you write the electronic configuration, it will be 1 only. Only 1 electron is there. And if you write the electronic configuration, it will be 2 only, because the first shell can have maximum number of electrons 2. You cannot exceed than that. So it has 2 electrons. So the first shell will have 2 electrons. So if you draw the structure of hydrogen, it will be like this. If you draw the structure of helium, it will be like this. So in both of these elements, the number of shell is 1 because they belong to the first period. Similarly, let us take another example, second period. I'm taking some elements: lithium, beryllium, boron, 3 only. I'm not taking all the elements because it is time consuming. So the atomic number of lithium is 3, is 4, it is 5. If you write the electronic configuration, it will be 2 1. If you write the electronic configuration, it will be 2 2. If you write the electronic configuration, it will be 2 3. Okay. If you draw the structure of lithium, it will have 2 electrons in the first shell, only 1 electron in the last Beryllium, it will have 2 electrons in the first shell, 2 electrons in the last. Boron, it will have 2 electrons in the first shell and 3 electrons in the last. So you can see in all of these cases all the elements have 2 shells only because they belong to the second period. Now I hope that the concept is clear to you, that in periods number of shells of each element belonging to that row, that horizontal row, is same. So number of shells remain fixed, number of shells remain fixed in periods, and number of valence electrons remain fixed in groups. So when you go down a group, you will find that all of the elements will have same number of valence electrons, and when you move across a period, you will find that the number of shells remain fixed.